Welcome today. I want to take you through this important practical paper, Practical Chemistry Paper 3. I want to let you know that Chemistry, Biology and Physics Paper 3 is going to be your savior in sciences. The paper in paper 3 carries 50% of the subject. So if you do more practice in paper 3s, you are going to score more in your final exam in sciences. So I want to take you through this paper, a very important paper, so that we can go. You are provided with 0.3 grams solid A, solid A, which is magnesium, and hydrochloric acid solution B, 0.5 sodium carbonate solution C. This one was supposed to be 0.5 molar solution C, methyl orange. So there is a letter that is missing here. This one is 0.5, 0.15 capital M solution C, and a methyl orange indicator. You are required to determine the enthalpy change per mole of the reaction between magnesium, metal, and excess hydrochloric acid. So remember, metal with hydrochloric acid, that reaction is a metal plus, which is going to give us salt plus a gas is going to be produced. And then if concentration in moles per liter of hydrochloric acid, solution B. Procedure. It is important for you to understand the procedure, what is happening in the procedure. Using a burette, measure 50 of solution B, and remember our solution B is HCl. Solution B is HCl. If you doubt, you go back and check. Place it in a 100 plastic beaker. Measure the temperature of solution B in the beaker after every 30 seconds and record it in the table. At the 90 second, add all the solid A provided into the beaker. Start with the thermometer and continue measuring the temperature and recording the temperature after every 30 seconds. Complete the table. So this table here from 0, remember it is the solution yenye umeweka ndani ya beaker 50 centimeters cube. So there is nothing you have added. So the temperature will be the room temperature. So in most cases, the room temperature, it depends to where you are. We will have 22 or 23, it depends, or 25, it depends. So in this case, we want to use 22.0. Because there's nothing you have added, it will remain 22.0. It will be a constant. 22.0. Always for temperature, record with 1 decimal place. So immediately it reaches 90, that is 30 seconds, 60, and then 1 minute, 30 seconds, that is 90 seconds. You add the solid A, magnesium. And then from there, the temperature will rise. So it rose, it can end up 43.0, it can end up 47.5, it can end up 48.5, and then ikaanza kushuka 47.5, 46, 40, that is to 10 is 47.0, 47.0 to 40 is 46.7, 46.5, and then 46.0. Record temperature using 1 decimal place. Plot a graph of temperature against time on the grid provided. So we are going to draw a graph of temperature against time. So remember to label the graph. So we are going to label the graph as you can see here. This is our graph of temperature against time. So nimeweka hizo points 22 ndio hii 22 22 22 22 as you can see, and then I have put the points there. So this is a graph of temperature against time. Na ukiangalia here we are doing energy changes. Energy changes, mtu mwingine anaweza fikiria ati sasa hapa anafaa kuchora curve. Unafaa kujua what are you dealing with. If you are dealing with energy changes, there is no day you are going to draw a curve for energy changes. No. Energy changes, there is no day you are going to draw a curve. So here, we are going to draw a straight line here. And then draw a straight. Take these points, uweke ruler, uangalie zile points zinachukua the maximum number of points, and then you draw a straight line. Ikishafika the last point hapa, you extrapolate the value, the line into to our reference point, which is 90. This X here remains, it is our reference point. X tuliweka kwa table. This X is our reference point here. Then you draw. So unachukua hizi points, hizi nne za mpande hii, you will draw the point, you will draw using these points, a line here, a line using these 4 points mpaka itafika hapa. So you extrapolate using dots this line to our X. Remember here we have X, that is the reference point. At this point here, this is where we have the maximum temperature. Maximum temperature. Remember that. So in energy changes, we don't have a curve. There's no way you're going to draw curves here. Remember that. So after that, now we are going to use this graph to answer the questions. I have drawn the graph for you. So let us use it to answer this question that is following. Determine the change in temperature for the reaction show. So ukisha extrapolate hapa mahali hii extrapolation dotted line inafika kwa hii curve, hapa ndio unasoma. So yangu imefika hapa, so unasoma hapa. Unapata kwamba hapa temperature, the highest temperature ingefika ni 50. So hatukufika 50, but the highest temperature ingefika ni 50. So that is the maximum temperature. Remember, temperature change is maximum minus minimum. So temperature change is equal to 50 minus initial, which was 22. I can use the decimal point, 50 minus 22.0, and the answer is going to be 28.0 degrees Celsius. So that is the temperature change. It is final minus initial, and our maximum temperature is 50. Na umeona venye nimepata hiyo 50. Calculate the heat change. The heat change is equal to capital M, mass of the solution, times specific heat capacity, times temperature change. Now, what volume of the solution did we use? We had put into the beaker 50 centimeters cube of solution of solution B. This is what is guiding us. The solution yenye ilitumika, because capital M, when we are calculating heat change, the M, it is the mass of the solution. Kama ni water, ama ni whatever. So now here you use the HCl. What was the mass? the mass was 50, the volume was 50 centimeters cube. But 50 centimeters cube is the same as 50 grams. Why? Because the density is 1. So 1 centimeters cube is equal to 1 gram. What about the 50 centimeters cube? Itakuwa 50 grams. So this is 50 grams. We divide it by 1,000 to change this one into kilograms, and then times specific heat capacity tumepewa 4.2 times temperature change, which is 28. So when you multiply this, you get it is 5.88 kilojoules. Kilojoules, J should be written in capital letters because it is the name of the owner who came up with this energy changes. So that is the heat change. Given that the relative atomic mass of magnesium is 24, calculate the enthalpy change for the reaction per mole. So what we are looking for is molar enthalpy. We are calculating molar enthalpy. Molar enthalpy for 1 mole. So first let us get the moles of magnesium. Moles is equal to mass over RAM. The mass was 0.3 divided by 24, and that one gives us 0.125. 0.00125. Moles. That is the number of moles. So this is the moles that produced 5.88 kilojoules. So we say 0.0125 moles was able to produce 5.88 kilojoules. Now, what about 1 mole? Because molar means for 1 mole, 1. So we will ask 1 mole will produce how much? So it is 1 times 5.88, you divide by 0.0125. This one gives us 470.4 kilojoules per mole. Kilojoules per mole. Before you move on, if you don't write the sign whether the reaction to show that to indicate that the reaction was exothermic or endothermic, you will get negative a half marks. So half is going to be deducted from the equation. Remember, this thing is given one mark. Umefanya mpaka umefika hapa, alafu unanyanganywa hapa mark because hukuweka sign. It is very painful. Umefanya kazi mingi, unapata hapa mark. Kwa hivyo to be care, to need, remember the reaction, temperature was increasing from 22, 43, 47, 48. So the reaction is exothermic. Whenever the reaction is exothermic, you indicate by writing the negative. Therefore, the final answer should be negative. So the answer should be negative 470 degrees, 470.4 kilojoules per mole, and that is the molar enthalpy. The negative shows that the reaction was exothermic. Procedure 2. Fill a clean burette with 0.15 molar sodium carbonate, solution C. So solution C is sodium carbonate, that is okay, 0.5, 1.5 ml. Place all of this mixture in the beaker, perform procedure this, into a volumetric flask. Now you need to understand the mixer yenye tuko nayo from procedure 1 ni mixer ya nini? Tulikuwa na magnesium ika-react na HCl. So hii HCl lazima ilikuwa in excess 50 centimeters, 0.3 iwezi maliza. So the solution that we have here in the beaker yenye tunaweka hapa ndani ni HCl. Ukumbuke hivyo because hii react ikatengeneza magnesium chloride plus hydrogen gas ikahepa So what we have is a magnesium chloride and excess HCl in the beaker after the reaction. Now we are taking this 50 centimeters, this solution in the beaker yenye tulipakisha from procedure 1 tuiweke kwa volumetric flask. We top up with water and then we label that solution D. So solution D ni nini? Solution D ni HCl. The difference with this one initially, this one is diluted, highly diluted, more diluted. It is more diluted. Hiyo ndio tofauti. Now we have put the remaining solution from procedure 1 in the beaker into a volumetric flask. We have added water to 250 and we have labeled that solution D. Now, pipette 25 of solution D. Remember, solution D is HCl diluted. Remember that. We are adding 2-methyl indicator, and then we have to titrate against using sodium carbonate, which is solution C. Remember now, what we have in the purette is solution C. What we have in the conical flask is dilute HCl, which is solution D. So what's happening here? Solution C, sodium carbonate, solution C, sodium carbonate is going to react with HCl. It is an acid base, it is a carbonate plus an acid. Hiyo ndio nataka na understand. Remember, hii ni C na hii ni D. Kama huwezi elewa hivi, sasa hiyo inakuwa ni shida. You need to understand the way I'm getting it here. So the table, I will give you the code after the titration. Remember to fill the table with 1 decimal place. Always. Initial, always write 0.0. Don't write anything else. 0.0, 0.0. And then put your 23.5. Sorry, this one is 23.8. 23.5 and then 23.5. Now, ukiwa umefanya practical na umepata 23.8, 23.5, 23.5. Ukiangalia hii range 23.8, 23.5 na 23.5, hii ya kwanza iko far away because accuracy inafaa kuwa plus or minus 0.2. Lakini hii ukiangalia imeenda 0.3. Therefore, this is an outlier. The value is outside. Therefore, tukifanya average, tutafanya na hizi mbili peke yake for you to get the accuracy marks. Sawa? Ndio maana nimeweka hapa intentionally ni kuonyeshe kwamba ukipata the value, ukiangalia hii decimal place na hii inaishinda by more than 0.2, then ukumbuke hautaitumia kwa average. Sasa hii itakuwa 23.8, 23.5, 23.5. Nikienda kutafuta average ya solution C, now I will do with 2, 23.5 plus 23.5 divide by 2, kwa sababu nikiweka hii itakuwa an error na sitapata accuracy marks. And this one will be 23.50 centimeters cube. Namna hiyo. So tushapata the volume of sodium carbonate 0.15 molar used ni hiyo. The next question is calculate the number of moles of sodium carbonate used. That's very simple because we have already the number of moles in 1,000. Remember, 0 sodium carbonate tulipewa 0.15 capital M. Capital M implies that moles, that 1 means that 0.15 is the number of moles in where? In 1,000 centimeters cube, in 1 liter. Kumbuka, capital M stands for molarity. It stands for molarity. And the molarity is the number of moles in a liter. In a liter, 1,000 centimeters cube. So whenever you see 0 point something capital M, Capital M stands for molarity, and the molarity is the number of moles in a liter. Sasa hii tulipewa 0.15 moles are contained in 1000 centimeters cube. We will find out ile volume yenye tumetumia sodium carbonate solution C is equal to 23.5. Yeah, it was 23.5 our average. Will be how many moles? Itakuwa how many moles? So you take your calculator, 23.5 times 0.15 divided by 1000. So unapata ni unapata ni 0.00352 moles. So this is the number of moles of sodium carbonate solution C used. Hiyo ndio imetumika ya C. Now the next question is calculate the number of moles of hydrochloric acid in 25 centimeters cube solution D. Now to get that, you must write a balanced equation for the reaction between HCl and the sodium carbonate. That is the only remedy. That is the only thing that will help you. It is to write a balanced equation. So let us write the balanced equation, that is HCl reacting with sodium carbonate, which is going to form the salt sodium chloride plus CO2 plus water. So that is the equation. Then balance the equation, because sodium hapa ni 2, you can put it 2 here and then 2 there. So from here, you don't need to write the status, because here the equation tunataka ikusaidie for balancing the equation only. Now, the number of moles of sodium carbonate tushapata ni 0.00352. And the mole ratio, as you can see, it is 1 to 2. 1 to 2. The mole ratio is 1, here is 1, and here is 2. So it means now moles of solution D is going to be twice this one. So you say, remember we had D to C, and the ratio is 1 to 2. And this one is 0.00352. So you say 1 is equal to this, what about 2? So moles of D will be equal to 2 times 0.00352, and that one is equal to 0.00705 moles. Very nice. So that is the number of moles. Hydrochloric acid, the number of moles of hydrochloric acid in 250. Now we have gotten the number of moles of hydrochloric acid in 25. What about 250? So you say 0.00705 is the number of moles of HCl solution D in 25 centimeters cube. 250 centimeters cube will be equal to what? So it is 250 times 0.00705. You divide by 25. So hiyo inakuwa ni 0.0705 moles. So that one will be 0.0. That is the number of moles of solution D in 250. Solution D. Now calculate the number of moles of the acid that reacted with magnesium metal. Sasa tunatuuliza tu ile magnesium metal yenye react into kianza procedure 1. Na hapa kuna information unafaa kujua. The information you need to know is very important here. Remember, magnesium reacted with HCl in the ratio. So you need to write the equation and check now. So magnesium reacted with HCl to form magnesium chloride plus hydrogen gas. We put it to here. Now we have the number of moles. We have the number of moles of HCl here. We can get the number of moles of magnesium. To know the number of moles of HCl and react, tuko na number of moles of magnesium. Remember, we calculated the moles of this tukapata ni 0.0125. Hii ni number of moles of magnesium yenye react na HCl mwanzo tukianza experiment. So tunataka kujua hii itakuwa ngapi, lakini you can see the ratio magnesium to HCl ratio is 1 to 2 from the balancing. Hii moles zake ni 0.0125. So itakuwa ngapi? Sitakuwa twice. So moles of HCl that reacted with magnesium is equal to 0.0125 times 2. Na hiyo unafinya calculator unapata ni 0.025 moles. This is the moles of HCl yenye react na magnesium initially kabla tukuje kwa procedure 2. Very nice. Now the question asks, calculate the total number of moles of hydrochloric acid in 50. Ile 50 yenye ilikuwa kwa bika, initial moles zake total ilikuwa ngapi? Total yake ilikuwa ngapi? Sasa tushapata moles yenye iko kwa 250. Moles yenye ilikuwa kwa 250 ni yenye ilikuwa imebaki after magnesium imereact na HCl. Na tumepata moles in 250 ndio hii hapa part Roman 3 which is 0.0705. Hiyo ndio moles yenye ilibaki in 250. Sasa tushapata moles in 250 na tumepata moles ya acid yenye react na magnesium. So how do you get the total? Total you just add. So it is 0.025 plus 0.0705. So you just simply add 559.0. So it will be 0.0955 moles. So hiyo ndio moles yenye ilikuwa kwa solution B originally. Very nice. Next thing is to determine the concentration of hydrochloric acid in moles per liter. That is simple. If now we have gotten the number of moles in 250 because tulianza na 250, tuliambiwa put 50 centimeters cube of HCl. So 50 centimeters cube of HCl tumepata moles zake ni 0.0955 moles. Concentration in moles per liter means molarity. Molarity is the number in 1,000. Number of moles in 1,000. Concentration in moles per liter ni moles in 1 liter, and a liter is 1,000 centimeters cube. Now 1,000 centimeters cube is equal to 1 liter. So we will ask 1,000 centimeters cube HCl itakuwa na how many moles? 1000 times 0.0955 divide by 50, na hiyo itakupea itakuwa ni 0.0955 times 2 times 2 times 20 times 20, yeah, because 50 inaenda kwa nini 20 times, ina mara moja, hii mara moja hapa mara 20, so the answer is going to be 1.91 capital M. Capital M stands for molarity. Molarity is the number of moles in a liter. Kama utaandika hivyo unaweza andika 1.91 mole per liter. Mole per liter. Very nice. Let me take you through qualitative analysis. You are provided with solid E. You are provided with solid E. Carry out the following test and record the observation in the inferences, the spaces provided. Place about 1/3 of solid E in a dry test tube. Heat the solid strongly. Test any gas with both litmus blue and red litmus paper. So once you put your red and moist litmus paper on the mouth of the test tube, make sure the test tube is very dry. That's one thing you need to do. The test tube should be very dry, should not contain any water or any droplets of water, because you need to make observation whether there is a colorless liquid formed on the cooler parts of the test tube. So that is the first observation, is that a colorless solution liquid condenses on the cooler parts, of the test tube. So ukiangalia hiyo test tube hapo juu utaona imesweat, inamaanisha iko na water of crystallization. So you can simply say hydrated salt. Solid E is hydrated. Or you can simply say hydrated salt. Or you can say it contains water of crystallization. It contains water of crystallization. Contains water of crystallization. Hiyo ni observation ambayo inakuja by the way, lakini the major thing we want to test the gas produced by litmus paper. That's where the main observation is. What happened? Did the litmus paper change to blue or not? Did the blue litmus paper remain blue or change to red? What happened? So you need to tell us. So the observation is that the red litmus changes. Don't write a tan, but write changes to blue, and blue litmus remains blue. So if that is the case, then it means the gas that was produced was a base, so that it can change now red litmus paper to blue. So if it is a basic gas, you can simply write basic gas present. It is allowed. Or you write ammonium ion. Ammonium ion present. color. No, white is not the thing. You write ammonium ion, positive present. Next, place the remaining amount of solid in a pouring tube. Add 15 centimeters of distilled water. Shake. Divide the solution into 4 test tubes, each containing about 2 centimeters cube. So the first portion, add 3 drops of diluted hydrochloric acid. Diluted hydrochloric acid, it depends. It will form a white precipitate, or we expect. And because you are adding HCl, the first thing we expect is effervescence. Whenever you are adding an acid to something, we expect effervescence. So the first thing is that we expect effervescence, but there was no effervescence. No effervescence. So whenever you are adding an acid, the first thing you expect is effervescence. So you check whether effervescence occurs. So if effervescence is not occurring, it means either the carbonate is not there, the sulfite is not there. Is absent. This one is absent. And then another thing we expect is that HCl ikiingia hapo, chloride ikiingia, ikutane na lead, itatengeneza white precipitate, lead chloride. Ikikutana na silver, itakutana na silver, itengeneza silver chloride, which is a white precipitate, silver chloride. But now there was no white precipitate, no white PPT. So if there's no white PPT, it means then lead, silver, H2 positive is absent. So these ones are absent. Next, to the second portion, add 2-3 drops of aqueous barium nitrate. Barium nitrate, we expect a white precipitate because barium will form a white precipitate with a sulfite, carbonate. Now, was there a white precipitate? Let's check. Yes, a white precipitate is formed. White PPT is formed. So a white PPT is formed. Then we expect normally for barium, the sulfite, the carbonate, the sulfite. Hii barium carbonate is a white precipitate. Barium sulfate is a white precipitate. Barium sulfite is a white precipitate. But initially tulisema carbonate na sulfite is absent. So hakuna venye tena utaziweka hapa. Hiyo ndio inaitwa elimination. So remember here in the previous tulisema that kwa sababu ya hii tukasema no effervescence, it means no white precipitate. Kwani hili jilidelete? Sawa. No white precipitate. Therefore, if that is the case, then no, we said here that no effervescence, the sulfite, the carbonate is absent. So usiilete tena hapa. Ukileta hapa utakuwa umecontradict. So this one is just SO4 2 minus present. That is the chemistry we are talking about. To the third portion, add aqueous sodium hydroxide dropwise. There we expect a white precipitate, either soluble in excess or insoluble in excess. There is something we had put here. Sijui kwa nini imepotea hapa, tulisema no white PPT. Na tukasema lead, silver, positive, absent. Absent means it is not there. So you will see now this one information hapa penye itatusaidia mbele kuamua ni nini tunafaa kuandika. Itatusaidia kujua ni nini tutaandika mbele. Next, sasa hapa tukifika hapa, we are adding sodium hydroxide. A white precipitate is formed soluble in excess. White PPT, which dissolves in excess to form a colorless solution. Dissolvable, soluble in excess. So a white precipitate soluble in excess, it means the ZAP is present. ZAP stands for zinc, stands for lead, stands for aluminium, and the amphoteric. So if you write zinc 2 present, aluminium 3 present, and then wewe ujui kueliminate umeandika 2 lead, now this one will cancel the whole answer. The lead will cancel the whole answer. This is correct. Lakini initially hapa tulisema kwamba lead hapa no white PPT, kwa hii no white PPT means that lead, silver is absent. So kama tulisema hapa iko absent, how come tena ukirudi hapa, ukikuja hapa utakuja kusema at iko present? Therefore you will go wrong, and that is why you will fail here. Therefore here we will have only zinc. We will have only zinc and aluminium present. Very good. Present. Ukiandika silver hapa, ama ukiandika lead, you get nothing there. You have cancelled the whole mark there. You get 0 kwa inference. To the fourth portion, add aqueous ammonia droplets until in excess. Then what happened? White precipitate is formed insoluble in excess. So white precipitate, white PPT, insoluble, which does not dissolve in excess, insoluble in excess. So if it is insoluble in excess, then it means zinc is absent, because zinc, when you add ammonia solution, zinc dissolves to form a colorless solution. Now it means zinc is absent, and if zinc is absent, then what is present is aluminium. So aluminium, 3 positive present. Zinc is absent, and they discourage negative answers. Zinc 2 is absent. For this one, you tell us what is present. Don't write what is absent, because we know what is present. We use absent where we do not have an option. But here we have option that the aluminium is present. Therefore, it is not encouraged to use the negative answer when we have the positive answer. So the cation present is aluminium. You are provided with solid F. Carry out the following test and record the observations and inferences in the spaces provided. Place solid one-third of solid F in a clean metallic spatula and burn it, burns a burner flame. So we expected the solid to burn because this is organic. How do you know this one is organic? When you read number 3, you will see we have the reagents that will guide us. We have acidified potassium permanganate. We have bromine. Now bromine will confirm that we are dealing with organic analysis. Organic analysis. So this one is organic. We expect you to write the double bond, triple bond, those things. So here we don't have cations and anions. Not at all. So did the solid melt? Did it burn? Yes. With which flame? Blue or yellow? CO2. So this one, solid F, melts and burns with yellow sooty flame. Yellow sooty flame, then it means unsaturated organic compound present. It is allowed for you to write unsaturated organic compound present. It is allowed, but if you want to write this one, unsaturated ni gani? Ni mbili, ni double bond. Make sure the carbons are 4 covalent bonds or triple bond. The carbon should have 4 covalent bonds surrounding it. So these ones are present. Tumesema unaweza tumia hii jibu ya juu ya maneno unsaturated organic compound present, or you write this one present. Place the remaining amount of solid F in this in a boiling tube. Add water. Check. Sasa we want you to tell us whether did the solid F dissolve in water to form a colorless solution? Yes. If yes, then you know what to tell us. Then the solid dissolved to form a colorless solution. Solid F dissolved to form a colorless solution. If that is the case, then it means that the compound solid F is polar. But polar meaning it is soluble in water. Polar means soluble in water. So if it is not, if it will not solve, then it is non-polar. Using 2 decimal, add test for determine the pH using a universal indicator paper and the chart. So you will take the solution. You after adding the universal indicator, check against the pH scale the color, and then look at the pH. So then, for example, this one the pH was equal to 2. pH 1, 2, 3 is a strongly acidic. pH 4, 5, 6 weakly acidic. pH 7 neutral. pH 8, 9, 10 weakly basic. pH 11, 12, 13 is strongly basic. For this one is strongly acidic. Strongly acidic. We are adding acidified potassium permanganate. The color for this one is purple. We expect it to be decolorized. If it is decolorized, then the double bond, triple bond, and the alcohol is present. If it is not decolorized, then the 3 are absent. They are absent. So purple, acidified potassium permanganate, potassium manganate changes to colorless or is decolorized. Changes to colorless. Or simply you can say acidified potassium permanganate is decolorized. So to decolorize means the color changes from purple to colorless. This word means that way. So if that is the case, then the double bond, the triple bond, and the alcohol is present. Those 3 are present. Now, this one is used to test for these three, but for the sake of elimination method, we had said here that these are unsaturated. Na ili burn with a yellow sooty flame. We know alcohols that burn with blue non-sooty flame. Now, if you come here and write, of course, the ROH will change the potassium permanganate purple to colorless. It will change, it will do so. Lakini kumbuka from the beginning pale tulisema haikukuwa because alcohols will burn with a yellow, blue, with a blue non-sooty flame. Now when you put it here, you contradict, and you're going to score nothing. Here, any price itakuwa 0. Therefore, please remember that is the chemistry we are learning. You are not going to include ROH here. The answer is going to be the double bond and the triple bond only. I don't know why my wrapper is not greeting this thing. Tafadhali, I hope umenielewa, na kama hujaelewa contact yangu iko over there kwa site kwa YouTube, so you can just contact when you have a question. This one is present. The reason why nimetoa alcohol despite the fact kwamba acidified potassium permanganate inatumika kutest for alcohol is because here F will burn with yellow sooty flame. Alcohols do not burn with yellow sooty flame. Therefore, if you include it here, it means you don't understand, you cram this content. But for understanding, you need to understand now, if it wasn't there in the first place, I cannot include in the second one. In the next subsequent test, I cannot include it. To the next portion, add 2 drops of bromine. So bromine, we expect the color to change from yellow to colorless, or we say it is decolorized. So bromine water, the color is yellow. You should know that. So bromine water, bromine water is decolorized. To decolorize means the color has changed from yellow to colorless. If that is the case, then it confirms that the double bond or the triple bond confirmed. Now we confirm that this is ndio zilikuwa because tushasema tumedoubt ndio zilikuwa present. Now we have confirmed that these ones are present because bromine inatumika tu kutest for these two. Thank you. Remember to share and subscribe as well. Share, subscribe. The year 2023, as you can see here, we have chemistry paper 3, the year 2023. Tuangalie jinsi ilikuwa inaonekana and then tuone what the students were supposed to do and what we're expecting in this year 2024. So here the students were provided with solution A, which is a mixture of sodium thiosulfate and starch. Solution B, aqueous potassium iodide. Solution C, aqueous hydrogen peroxide. Solution D, 0.01 molar potassium manganate 7. So the students were required to determine the concentration in moles per liter of hydrogen peroxide in solution C, and then the rate of reaction between hydrogen peroxide and potassium iodide. So 2023 we had the rate of reaction. So you should not expect the rate of reaction this year. So you should do things like energy changes graphs. Yes. Yeah. So this year prepare energy changes. Those graphs that are found in energy changes. Molar heat of neutralization, molar heat of combustion, all of those graphs. Those are the things you need to prepare for this year. So let us go through the procedure 1, where we have the titration part of it. So one thing I want to explain here is about when you are given something like 0. Here we have 0.01 capital M. Capital M, you had me mention here 0.01 molar. What it means is that it is the number of moles in 1 liter. Molarity. So this is molarity. And what is molarity? Molarity is the number of moles in 1 liter. So simply this means that 0.01 is the number of moles found in 1000 centimeters cube. That is what it means. Very important. So whenever you are given, even if when you are given 0.5 capital M, this means number of moles where in 1000 centimeters cube. So long as it is capital M, that is molarity, and molarity is the number of moles in 1 liter. Using a pipette and a pipette villa, pipette 25 of solution E, solution C, into a 250 volumetric flask. Add distilled water to the mark and label this the solution as solution E. So remember now, solution E is solution C but diluted. So solution C tulikuwa nayo ni nini? Hydrogen peroxide. Right? Now fill the puree with solution D. And remember, solution D is potassium permanganate. Fill the puree with solution D using a clean pipette. Place 25 of solution C into a 250 conical flask. Titrate with this until permanent pink. So there was no indicator because this is a redox reaction. So let me take you through how to fill the table. This table has got 4 marks, as you can see. It has 4 marks. So there is a mark for the decimal point. I want to encourage you to use 1 decimal point. And here, assume that every time you are doing the experiment or the titration, you are starting from 0. So when the reading is 0. So you feel this initial should be 0.0. Assuming that you every time ukimaliza una fill. So itakuwa 0.0. Make sure you have 1 decimal place. So yeah, the volume was 16.9. This was 17.0, 17.1. So when you look at this 17.1, it's in a course, they are in the plus or minus 0.2. This one. So it means wakati unaenda kufanya average utatumia zote. So when you subtract this one hapo utapata ni 16.9, 17.0, 17.1. So this is how you fill the table to get 3 marks if it is not accurate. But if your titration is accurate, then that is the 4 marks you will score there. Average. So average you will do with those that are very close 0. So if you look at 16.9, 17.0, all these ones are at a very close range, so we are going to do the average with all of them. So itakuwa ni average is equal to 16.9 plus 17.0 plus 17.1 divided by 3. You divide by 3. Kwa mfano hapo ungepata hapo upate 17.5. Ungefanya average na 3, ungefanya average na hii peke yake. So you are going to do 16.9 plus 17.0 divided by 2. Kwa sababu this one is an outlier, is very far away from the accuracy. Kwa sababu 5.1 is this one is very far, so you leave it out. So in this case, we are going to have 17.00. Make sure your average is in 2 decimal places, and then you write centimeters cube because that is the average of solution D used. Lakini kabla tuende sana, lakini hiyo nita explain as we move. Let us look at what the first question is asking. Second, calculate and determine the number of moles of potassium manganate that reacted. So solution D ni nini? Unarudi hapa, unaangalia solution D is potassium permanganate, because you need to understand what you are using. So solution D is potassium permanganate, meaning the volume yenye tumetumia, the average volume we have here, this is the average volume of potassium permanganate solution D, right? So we are asked to find the number of moles of potassium permanganate solution D that reacted. So this is D. So what that means is that unarudi back kwa what you are provided to. You are provided with 0.01 mole of solution D. So you say 0.01 is the number of moles present in 1000 centimeters cube. So we will find out 17 centimeters cube will contain how many moles? Yes. So we will say it is 17 times 0.01. You divide by 1000. And this one will give us 0.000017 moles. So the number of moles of solution D that reacted is 0.0017 moles. That is not the only way you can do it. You can use a formula. There's a formula that I usually give here most of the time. There's a triangle I usually give here. That is method 2. You can use this one. You can say, we know that molality here we have moles, here we have volume in liters, volume which must be in liters. So what we want is the number of moles using the formula. How do you get moles? From the formula, moles is equal to molality, let me use capital M for molality, times volume in liters. So the volume for solution D is 17. So that volume should be in liters. So our molality is 0.01 for that D. So you divide it by 1000 to convert centimeters to liters. So when you do this, you find that the answer is 0.00017. And that is the number of moles. So you can either use this one or use the simple concept of moles. So that is the way to go. Next one. Determine the number of moles of hydrogen peroxide in 25 solution E. 5 moles of hydrogen peroxide reacted with 2 moles of potassium. So we have been given the mole ratio. We have been given the mole ratio, and that makes the work very easy. So remember, E reacted with D. So what we have, the reaction that took place is D which reacted with E. And it gave us whatever it gave us. We don't know why we can write that. So now we are not interested in the equation, but you need to know that it is D, potassium permanganate, that reacted with E. And the E was diluted from C. You should know that. So hapa kitu tumeshapewa moles, molality or the mole ratio. So mole ratio tumepewa, so tulianza E D. So solution E, 5 moles of hydrogen peroxide. Hydrogen peroxide in solution E. So they were 5, which reacted with this one 2. But remember, we have moles of D. About to calculate it. What we have calculated here and above here is the moles of D. Remember, manganate is D. So what we have is the number of moles of D. Kwa sababu we react with this ratio, so we can get the number of moles of E in 25. So here, the number of moles here is 0.00017. So we will ask here what will be the moles. So simply, so we will ask that if 2 is equal to 0.00017 moles, 5 will be what? So it is 5 times 0.0017, you divide by 2. So the number of moles of solution E in 25 will be, you multiply that, you will get it is 0.0000425 moles. So this is the moles of E in 25 centimeters cube, because 25 centimeters cube of E reacted with 17 centimeters cube of D. Hapa unafaa kuelewa what is happening, so that you can be able to flow smoothly. Now, concentration of in moles per liter of hydrogen peroxide in solution E. Concentration in moles per liter. Concentration in moles per liter means molality. You need to know that concentration in moles per liter simply means molality. And the molality is the number of moles per liter, right? So if we have the number of moles of E in 25 centimeters cube, so what will be the number of moles in 1,000? Because a liter is 1,000. As simple as that. So we will ask, we know the number of moles of E in 25. Tumepata kwamba 0.0002425 is the number of moles of E in 25 centimeters cube. 1,000 centimeters cube, because 1,000 is equal to the liter, will contain how many moles? Will contain how many moles? So this means that we will multiply 1,000 times 0.00425, we divide by 25, and this one will give us 0.017, capital M standing for molality. You can as well use the formula I gave here. You can use this triangle and you will get molality. You will use that triangle and you will get molality. So if I use the triangle, let me use here the triangle for those who like using the formula. From the triangle, molality is equal to moles over volume in liters. So the moles ya hii tumepata ni 0.000425. Volume yake ni 25, but this 25 should be in liters, so you divide by this one to get liters, and you realize that ukifanya hivi, ukifinya hii itakuwa ni this divided by 0. Let me just go direct. Itakuwa 25 divided by 1000, itakuwa 0.0. That's what I want to do. So that one will be 0.0. 1000 divided by 25. So 25 over 1000. Hii na hii itakuwa 0.025. So when you divide by that, you will get the answer to be 0.017 capital M. Capital M stands for molarity. We will move to the next question. Concentration in moles per liter of hydrogen peroxide in solution C. Very, very important. So here, that's what I want you to understand. Remember what we did. Solution E ni nini? So let me take you back here. Solution E, this is where you need to understand. Solution E is actually sodium and hydrogen peroxide. Solution C acquires hydrogen peroxide. So what happened? We took 25 of hydrogen peroxide solution C, tukaweka kwa 250 volumetric flask. So tuliweka 25 tukaongeza maji, distilled water, ikafika 250 sawa centimeters cube. What it means is that number of moles yenye itakuwa kwa 250 solution E will be equal to the number of moles in 25 solution C. Did you hear that? I said when you dilute a solution, the number of moles does not change. What changes is the concentration. So if I took 25 centimeters cube of solution C, I added water to 250. The number of moles in the 250 solution E will be equal to the number of moles in the 25 solution C from the original solution. I hope that one is well understood. So having that knowledge now, we go back to answer the question that we asked it to answer. Calculate the concentration in moles. So we need to start by understanding that the number of moles in the 250 solution E will be the number of moles in 25. Very important. Understand that moles in 250 centimeters cube solution E will be equal to number of moles will be equal to the number of moles in 25 centimeters cube from where we got it. Yes. So if that is the case, then we know the number of moles in 25 we can know the number of moles in 250 because we know the number of moles in 25 solution E. We also know the number of moles of E in 1000, so that's no big deal. So we can say 25 centimeters cube E is equal to 0.0040425 moles. We will simply ask 250 centimeters cube will be what? So it is 250 times 0.000425. We divide by 25. And this one will give us 0.00425 425 moles. This is the number of moles in 250 solution E, right? But we know that the number of moles in 250 will be equal to, so meaning moles of 25 centimeters cube C is equal to this one, 0.00425. So we are being asked the concentration in moles per liter, molality of solution C. So we will ask that 25 centimeters cube C has got 0.0425 moles 1000 centimeters cube will contain how many? So it is 1000 times 0.00, no, is it 02? Yes, 0425 we divide by 25. So the original solution C, hydrogen peroxide, ilikuwa na 0.17 capital mol m, molality yake ilikuwa hiyo. Very, very important to note. So that is how we were supposed to handle the titration in 2023. Now, procedure 2 was for what? For the rate of reaction. And I'm not going to do a lot on that because I don't expect the rate of reaction this year, so there's no need of wasting time. We expect energy changes graph or another, but the rate of reaction, I don't think so because it was there last year. So I don't think it will come again. But in case it comes, no problem. You can be able to handle. So but whenever you are given the rate of reaction, because this table you can fill because you will do the experiment, but if you want to know the values, I can give you the values if you need. So these values, this one, the time the rate was going from 39.00, that was the first time, then there was 50, then there was I think this is the one that we used to draw the graph, yes, then there was 66.67, there was 75.00, there was 80.00. so when you do the reciprocal of that, you will get 25.64, 20.00, 15.00, 13.00, 12.50. So that's how you are supposed to do. Remember the graph, this table should be having 4 significant figures. You should remember that. So I am not interested in that, but I want to encourage you about the graph. Any graph that is dealing with rate, the line should be a straight line, and that line should pass through the origin. Should be, even when you extrapolate the line, it should pass through the origin. That is the keyword. So this line inaweza kuwa inafika hapa, lakini wakati una extend hii line lazima ipite kwa origin. That is the graph for rates. So you need to know that. So let me take you through qualitative analysis, because you will get the same thing this year. This one will repeat, you will see, because it will not change much. So the first thing we had in the qualitative analysis, you are provided with solid F. Carry out the following tests and record the observation. Describe the appearance of solid F. That may not be the case this year. You may not be asked to describe. So, but this one, they were supposed to look at the solid, and when they were looking at that solid, it was pale green. So they were supposed to write this. It was pale green. It was pale green crystals. The crystals were pale green. So that is what they were supposed to write. And then This one, even this year, you can find it. Place about 1/3 of the solid, dry test tube. Heat solid gently and fast, then strongly. Test the gases using a brew and red litmus paper. A very common question. So that's why I want us to go through this one. So we expect several observations here. We expect several observations there. First, tell us what happened when the solid was being heated. Did you see water of crystallization? Yes or no? So in most cases, when you heat a substance, we expect for you to see a colorless liquid formed. So the first thing we want to see is that a colorless liquid is formed where? At the cooler parts. Of the test tube. Whenever you heat a solid, we expect you to tell us that there's a colorless liquid which is formed. Because when you look at the top, unaona ni kama hiyo test tube inakaa ina sweat. So that's what we are talking about. It contains water of crystallization. So when you have written this observation, you tell us that this salt might be containing water of crystallization or it is hydrated. So hydrated salt contains water of crystallization. So you simply write hydrated salt. Hydrated solid. If the word hydrated solid disappear, then you just write solid F or solid F contains water of crystallization. Contains water of crystallization. You can use that one. That is not the now. The second thing is, what happened to the litmus paper? Did the red litmus paper remain red, or did it change to blue? Did the blue litmus paper change to red, or it remained blue? So in this case, the red litmus paper was changing as follows. So red litmus paper changes to blue, and then blue litmus paper, while blue litmus paper remain blue. So what is that is present that changes red litmus paper to blue? It means the gas that was produced is basic. It is a base which changes red to, it is a base which changes red litmus paper to blue. So you can say basic gas present. So there is two ways of writing the answer now, the inference. You can simply say basic gas present, or you can use ammonium ion chemical formula to show that ammonia gas is present. Ammonia gas is the only gas that is basic. So you can say ammonium ion present. You can use the first one or the second one. You don't need to write both, but you use just one of them. Place the remaining solid in a test pouring tube, add 15 there. Divide the solution as you have been told. Measure the pH of the first portion using a universal indicator paper. That might not be the case this year, but it is important if it appears again. If it reappears, what are you supposed to do? Is to check and then take the pH scale test. Look at the color. You take the solution in the test tube, you check with the pH ile umepewa iko na from 0 na hizo colors mpaka 14. You check, unalinganisha namna hii. Unalinganisha, unaona hii solution inakaa na color gani. Ukiona inakaa kama red inamaanisha inakuwa 1 or 2. Inakaa yellow hiyo ni 6 hapo. So for this case the pH was equal to 5. So pH of equal to 5, then it means the solution there was a very weak acid. So you simply write weakly acidic. So if it is 3-1, strongly acidic. If it is 8, 9, 10, 11, weakly basic. For 12, 13, 14, strongly basic. This one is a must. You will find it this here, sodium hydroxide solution. Whenever you are adding sodium hydroxide dropwise until in excess, we expect ZAB. We expect ZAB, which is the amphoteric oxides, which is zinc, aluminium, and lead. So these are the things we expect. So when you put sodium hydroxide dropwise until in excess, then we expect a white precipitate to be formed. If a white precipitate is formed, then ZAB is present. If a white precipitate is soluble in excess, then ZAB is present. A white precipitate insoluble in excess, then magnesium and calcium present. But if you see a different color, it's not a white precipitate like green precipitate. For this one, it was green. So this here, we must have a white precipitate soluble in excess, a white precipitate insoluble in excess. But using the same reagent, sodium hydroxide, we repeat the first one, I guess. So in this case, it requires a green precipitate, a green PPT, insoluble in excess, a green precipitate insoluble in excess sodium hydroxide. So that means then, if green PPT, remember green stands for ion 2, brown stands for ion 3, blue stands for copper 2, copper 4, copper 2, yes, copper 2. So this one was Fe2 positive present. To the next portion, we were adding to the third portion, add 3 drops of aqueous barium chloride, shake the mixture, and add 1 centimeter of dilute hydrochloric acid. So a white precipitate is formed, which does not dissolve in HCl. So here, a white PPT. Remember, whenever we are using barium, we expect white PPT or no white PPT, because barium forms a white precipitate with the sulfate, the sulfite, and the carbonate. So white PPT, a white precipitate, which does not, because we are adding again white PPT, which does not dissolve in the acid, in the HCl. So if the white precipitate is formed and is not soluble, it does not dissolve in the HCl, then what is present is the sulfate ions. If it dissolves to form a colorless solution, then the means CO3 and the sulfite is present. So ikidissolve hiyo white PPT, ukiweka acid na idissolve ikuwe colorless, this and this is present. If it does not dissolve to form a colorless solution, then this one is present. To the fourth portion, add 3 drops of aqueous hydrogen peroxide, shake the mixture, and then add aqueous ammonia dropwise until in excess. This year, I don't expect such, so we are expecting something different, but ammonia solution will be there. Ammonia solution reagent is a must. So round hii tunaweza kuwa na white precipitates, sio green. I'm doubting, I'm trying to know that. So what happened there? To the fourth portion, add that hydrogen peroxide, and what was the observation? A brown solution is formed, brown precipitate insoluble in excess. So the first add aqueous, so a brown BPT, a brown precipitate. First, remember we are adding to the first portion, add aqueous hydrogen peroxide. Shake the mixture and then, so there is 2 steps that we are going to do here. We are doing 2 steps. So let me not start at a PPT. Ni kama nimeruka. So first, a brown solution is formed. So if a brown solution is formed, remember what we had initially is green, and now it has formed brown. So it means ion 2 has been oxidized to ion 3. So you simply write ion 2 oxidized to ion 3. Hivyo tu. Then now, for adding ammonia dropwise until in excess, now the brown PPT is formed. Brown PPT, which does not dissolve when insoluble in excess. In excess ammonium hydroxide. Then what that means is that ion 3 confirmed or present. Ion 3 present. That is what it means. So qualitative analysis is a free marks because the reagents will be the same things. So I don't know why students want to fail in qualitative analysis. This one is an organic compound. You were told now this one umeambiwa, so you don't need to struggle. Place already this distilled water, shake well. So when you put this one, you would want us to tell whether it is polar. If it dissolves, it is polar. If it does not dissolve, it is non-polar. So in this case, the solid G dissolve to form colorless solution. So if it dissolves to form a colorless solution, then it means polar organic compound present. So solid G is a polar organic compound. Polar. Use about 2 cm of portion and then test the following test. To the first portion, add sodium hydrogen carbonate. Sodium hydrogen carbonate is trying to test for the presence of an acidic organic acid. So we expect effervescence, bubbles of a colorless gas produced. So effervescence occurs or it does not occur. So if you add sodium hydrogen peroxide, sodium hydrogen carbonate or sodium carbonate, no effervescence, we are going to see what to write. Effervescence occurs, what we are going to write. So here we expect effervescence to occur or not to occur. Whenever you are adding sodium hydrogen peroxide, hydrogen carbonate, expect effervescence. This one will not miss. You will tell me if you wish. Effervescence. So this word always gives to students a hard time. Effervescence. effervescence occurs. But if this word gives you a problem, just write bubbles of a colorless gas. So once you write bubbles of a colorless gas, you mean effervescence has occurred. So you can use it, or ukiona hiyo bado imekuwa ngumu, you can say fizzing occurs. Fizzing occurs. So either of the three, you pick one. So if that is the case, then it means an organic acid is present. And the general formula for, the general presentation of organic acids, like carbonic, not carbonic here, but carboxylic acids, like ethanoic acids, butanoic, we use RC00OH present. So if there was no effervescence, you write this one absent. Absent. Potassium manganate will not miss this here, so this reagent will be there, whether you like it or not, you will tell me. So this one is used to test for double bond, triple bond, and alcohol. So if the color changes from purple to colorless, then alcohol is present, double bond is present, triple bond is present. So what was the observation? Potassium permanganate is decolorized. So to decolorize means the color changes from purple to colorless. So potassium permanganate, acidified potassium permanganate, acidified potassium permanganate, permanganate 7, is decolorized. This word decolorized means the color changes from purple to colorless. So if that is the case, then you should note the double bond or the triple bond or the alcohols. Sorry, the alcohol is 1O. The alcohol is present. So either these three are present. Make sure the carbon atom is surrounded with 4 covalent bonds. Now what is going to identify now to differentiate from this one is acidified potassium dichromate. This one is used to test for alcohol only, OH. So if the color changes from orange to green, then alcohol is present. If it doesn't, then the alcohol is absent. So orange, acidified potassium dichromate 6 changes to green on warming. So if it changes to green on warming, then it means that the alcohol is present. So this year, these things will be there, and you don't need to miss anything. So if they can add some bromine water, no problem. I have explained so many times how to use bromine. What they can add here is bromine. There's nothing more or different that is going to come. Thank you very much. Enjoy your time.